वॉइस नहीं आ रही है सर।
हेलो, अभी बताइए, अभी आ रही क्या? अच्छा, अभी आ रही है, ओके ठीक है।
ईयरफोन यूज कर रहे हैं सर?
हाँ हाँ, ईयरफोन यूज कर रहा है।
ठीक।
हमें लगता है उसको करने पे नहीं आ रहा है सर, मैंने कंप्यूटर ऑडियो किया दोबारा करा सर।
हाँ हाँ, ऑडियो ज्वाइन ऑडियो करेंगे तो आएगा।
हाँ ठीक है, हो गया अभी।
ओके।
ठीक है, अभी आ रही, चलिए ठीक है, पढ़ते हैं फिर हम लोग।
हाँ, बाकी वैभव दिवाहर, you people can reply to sir comment, okay?
ओके सर।
हाँ।
ओके, तो in previous class we have learned about effective atomic number, right? That is EA rule. EA rule. Today's class we are going to discuss about metal carbonyls, metal carbonyls, and about metal nitrosyl. मेटल नाइट्रोसिल। नोट्स के बारे में भी परेशान मत होइए आप लोग, बस ओनली सो you just try to understand the concept and try to match frequency with them so that you can understand everything in the upcoming classes. So don't worry about notes, just what I am going to explain you just try to understand, and whatever doubt come during the classes then you can ask me, right? First I'm going to talk about complex formation tendency. That is why there is chemistry or a subject based on D block metal, like coordination chemistry or organometallic chemistry. You all know that coordination chemistry or organometallic chemistry is only based on the D block metals, right? Why it is so? Okay beta, okay, ठीक है, okay. So it means that the complex formation tendency of D block complexes or D block metals, we can say, is much better as compared to S block metal or P block metal or even F block metal. Why it is so? This is why, because the complex formation tendency.
एक्सक्यूज मी सर, सर स्क्रीन नहीं विजुअल, स्क्रीन सबको दिख रही है क्या?
हाँ, शेयर किया है स्क्रीन।
ये सर अभी दिख रही है
ठीक है,
सामने।
ठीक।
ओके,
ठीक।
so complex formation tendency basically depends upon two parameters, right? Directly proportional to what? Charge density, right? Charge density means charge upon size ratio. Charge upon size ratio, right? In case of B block metals, size is not much large as compared to in case of P block or in case of S block. It doesn't mean that D block metal size is smaller as compared to S block or size is small as compared to P block. It means the increment in size of D block metals is not as regular as compared to increase in size of S block metal and in size of P block metal. This is because of what? This is because of introduction of electron in d orbital, right? ऐसे लिख सकते हैं irregular increase in size, right, due to electrons in d orbital, right? Why it is so? Because d orbital has poor shielding effect. That means d orbital has poor shielding power. That means repulsion is not much effective as compared to repulsion in P block as compared to repulsion in S block. Poor shielding due to more nuclear force over outer cells, more nuclear force over outer cells, right? Hence, smaller size. Smaller size means the size is not as much as large as compared to that of size of S and P block. Got it? Means increment in the size of D block metal is not as regular, is not as large as compared to increase in size of S and P block metal, because filling of electron in D block metals or D orbital leads to poor shielding, which is why there is more electrostatic force of attraction or more nuclear force over the outer cell. In case of S and P block metal, S orbital and P orbital has more shielding effect. Therefore, the outer cell of S and P block metal experience less nuclear force. Therefore, there is more increase in size on going from top to bottom in case of S and P block metal as compared to D block metal. It means size increment in case of D block metal is not large as compared to, is not much as compared to S and P block. Means this parameter is not much effective, that is, this is less, due to which charge density will be high, or high charge density and charge also plus 2 plus 3. That means you have learned about that D block metals have variable oxidation state, that is plus 2 plus 3 plus 4 plus 5, even in some cases plus 6, right? In some cases plus 8 also, not in individual state, but in case of some compound, with some compounds it's also there. So this parameter is also very large, this parameter is small. Therefore, charge density is very high, hence they have more complex formation tendency, right? Why size is less? Why size is not large as not much large as compared to S&P block? Because of filling of electron in d orbital leads to poor shielding and more nuclear force over outer cell, which is smaller size. That's why d block complexes have more complex formation tendency, due to which there is coordination chemistry as well as organometallic chemistry, which is based on mainly on the metals. Those belong to D block metals or D block. Clear? Is it clear to everyone?
Sir, why poor shielding when this is inner d orbital? Like if this is inner d
listen.
orbital, it is more.
Okay, listen. This is the nucleus, right? S orbital is here, p orbital is here, right? D orbital is like this. If electron is filling to these orbital, then these are the closer to nucleus. Therefore, they will repel to p orbital strongly, right? Also, if electrons are filling in p orbital, they will seal d orbital. First thing. Second thing is the s orbital smaller size, right? Yeah, ऐसे बोलते हैं size of orbital s smaller फिर p then d. अब ध्यान से सुनना. Large size orbital as compared to d orbital, small size orbital. Each orbital has maximum how much electron? 2, according to Pauli's exclusion principle. 2 electron here, 2 electron here. In large size orbital, if there are 2 electron, then electron density will be low, right? Because volume is higher, then density will be low. Electron density is low. Here, electron density is more. Electron density is more due to smaller size is more, right? Then if electron density is low, then repulsion power will be also less. Repulsion power will be less because at every point there is less electron cloud. In case of s orbital, at every point as compared to d orbital, there is more electron cloud. Then if there is outer electron coming to nucleus, if any outer electron which is coming to nucleus, then s orbital will strongly repel as compared to d orbital. And this repelling power is called what? This repelling power is what called shielding power. Shielding power. And effect is also effect, shielding effect, right? So due to smaller size, more electron density, more repulsion. Larger size, less electron density, less repulsion. Less repulsion means less shielding power, less shielding effect, less shielding effect. Right? Is it clear?
Sir.
Yes,
Yes, sir.
Sir, one thing I said, like this, in cases of transition metals, we have inner d orbital. So this position of SPD should be reversed, right? D should come before S, like 3D will come before 4S. In terms of electron filling, we'll do for 4S before then D, but
हाँ ये
in
पिछली क्लास में
terms of,
समझाया था. In previous lecture I have explained this. फिर से बताएं?
ये सर को बता दीजिए.
हाँ ठीक है. Okay. Listen. This is the nucleus, right? Consider this is the 3D orbital. For example, I'm taking example of 3D series, right? The 3D orbital. This is the 4s orbital, right? Then 4s orbital, listen, plus 4, this is the positively charged nucleus. We know 4s orbital has more penetration power as compared to 3D orbital. So when there is no electron in 4s orbital and 3D orbital, then 4s orbital is more closer to nucleus as compared to 3D orbital. When there is no electron in 4s orbital and 3D orbital, when you are going to fill electron, then your electron is first entered into 4s orbital. After that, electron is entered into 3D orbital, right? So 4s electron, 2 electron, and 3D orbital, right? This is the filling of 4s electron. When you are going to enter or going to fill electron in 3D orbital, then there is repulsion between 4s electron and 3s electron. When there is no electron in 3D orbital, there is no repulsion. When there is filling of electron in 3D orbital, then there is repulsion between 4s orbital electron and 3D electron. Due to repulsion, these two orbitals become at more distance from each other, leading to 3D orbital to remain inner side and 4s orbital to become outer side. But when there is electron in both 3D orbital and 4s orbital, when there is no electron in 3D orbital and 4s orbital, or when there is electron in only in 4s orbital, then energy of 4s orbital is low, 3D orbital is high. However, when electrons are present in both 4s orbital and 3D orbital, then energy of 4s is high and energy of 3D is low. Due to what? Due to repulsion between 3D and 4s orbital, right? That is why when we are going to fill electron, we first fill 4s orbital, while during removal of electron will also remove the electron from the 4s orbital. This is the qualitative explanation what I am giving to, right? Qualitative. Quantitative explanation you can explain, yeah, you can get from quantitative data, you can get from Slater's rule, right? Slater's rule. By Slater's rule, you can get, yeah, you can calculate effective nuclear force on every orbital, either 4s orbital or 3d orbital, so that you can predict whether from which orbital, 3d orbital or 4s orbital, electron is going to remove. ओके, क्वालिटेटिवली आप यहाँ से समझ सकते हैं, क्वांटिटेटिवली आप स्लेटर रूल से भी बता सकते हैं, आपको यहाँ पे कैलकुलेशन करके बता सकते हैं, यहाँ पर क्वालिटेटिवली ऐसे समझ सकते हैं. ओके,
Yes, sir.
ठीक है, आगे चलें.
Yes, sir.
Yes, sir.
So is it clear that why complex formation tendency of D block complexes is greater as compared to SNP block? Because increase in size is not as smooth as compared to SNP block because of poor shielding by d orbital, hence more nuclear force over outer shell, therefore size is less. Also because of d orbital, because d orbital has poor shielding power, hence electrons are loosely held, they have variable oxidation state, that is +2, +3, +4. It means they have high charge density as well as smaller size, leading to more complex formation tendency, due to which there is two broad categorization of chemistry terms, that is coordination chemistry and organometallic chemistry, which is mainly based on the complex formation behavior of the D block metals. Is it clear? Now, these are the D block metals. D block metals can show both low oxidation state as well as high oxidation state, right? Low oxidation state means -2, -1, 0, +1, right? Like this. High oxidation state means +3, +4, +5, +6, right? etc. D block metals form complexes in both these oxidation state, low oxidation state and high oxidation state, right? Low oxidation state means what? Metals are electron rich, right? High oxidation state means metals are electron deficient, right? If metal is electron rich, then it will try to bind those surroundings or those ligands or those groups which has tendency to accept electron, right? Tendency to accept electron. When metal is electron deficient, then it will try to bind to those systems which are electron rich. तो यहाँ किस ग्रुप से जुड़ेगा? ग्रुप tendency to donate electron, right? Those systems or those groups which has tendency to accept electron are called acceptor ligands, right? बोल सकते हैं, these are called acceptors and these are called donors. If metal in low oxidation state also form pi bond ligand, या pi bond, then such groups are called pi acceptor groups. Pi acceptor group or pi acceptor ligands, right? It means if metal in low oxidation state undergo bonding with ligands which is also capable to form pi bond with metal, then such ligands are called pi acceptor ligand, either pi acceptor ligand or pi acid ligand, right? Pi acid or pi acceptor ligand. right? Similarly, in case of here, if in such cases when metal also form pi bond, then such kind of groups are called pi base or pi donor ligand. Means when metal is present, when metals are present in low oxidation state and they are going to form pi bond with surroundings or ligand, then such ligands are called pi acid or pi acceptor ligand. However, when metals are present in high oxidation state and they are going to form pi bond with ligand, then such ligands are called pi base or pi donor ligand. Why pi acceptor, pi base? Listen. Each ligand has tendency to donate one lone pair. Every ligand, either pi acceptor or donor, everyone, right? And leads to formation of what? Sigma bond. If metal is electron rich, then it will try to remove its high electron density, and metal will remove its electron density by donating its electron cloud to the vacant orbital of this ligand. Sigma bond is already formed. During donation of electron density, it will form pi bond, right? By donating its electron cloud the vacant orbital of ligand. In this case, pi bond is formed by metal, pi bond is formed between metal and ligand, and electron is donated from metal to ligand, right? That means pi bond is formed, pi bond is formed where ligand is accepting electron pair, right? That means pi bond formation occur when ligand is accepting electron pair from metal. That means this is pi acceptor ligand, right? Pi acceptor क्यों? Because pi bond is formed where, in this case, pi bond is formed by donation of electron from metal to the vacant orbital of ligand. That means ligand is accepting pi electron from metal to form the pi bond. If metal is electron deficient, right? That means metal has low electron density, then sigma bond तो बनेगा ही सबके केस में. In this case, ligand will donate electron pair to the vacant orbital of metal. In this case, ligand is donor because ligand is donating electron to the vacant orbital of metal. And pi bond is formed by donation of electron from ligand to the metal. And such ligands are called pi donor ligand, right? Example of pi acceptor ligands are carbonyl, nitrosyl, phenanthroline, right? BPY, right? Cn minus etc, right? Pi donor ligands example O2 minus, right? Br minus, Cl minus, right? OH minus. These are the example of pi donor. NH2 minus, right? NH2 minus. These are the example of pi donor ligand. How can we identify whether any ligand is pi donor or pi acceptor? Listen. If any ligand has one lone pair, right? AB कोई ligand है. If any ligand has one lone pair and it has vacant orbital, which kind of vacant orbital? Pi star or d orbital. Pi star कैसे होगा? For pi star orbital, it must have multiple bond. It means any ligand in which donor atom has one lone pair and donor atom is bonded to other atom via pi bonding, then it can behave as pi acceptor ligand, right? For example, CO, listen, one lone pair and carbon is bonded with multiple bond. NO, one lone pair and nitrogen is bonded with multiple bonds. Similar phenanthroline, similarly BPY, similar Cn minus. Carbon has one lone pair and carbon is bonded to multiple bonds. Then you can identify any ligand in which donor atom has one lone pair. One lone pair चाहिए, one से ज़्यादा नहीं. One lone pair and donor atom is bonded to multiple bonds. Then this ligand can behave as pi acceptor ligand. Is it clear? Why these ligand are pi acceptor? Because they can this can form only sigma bond, right? And this metal electron cloud is going to pi star orbital. That's why they behave as bisexual ligand. So any ligand in its donor atom has one electron pair, that is one lone pair, and donor atom is bonded to multiple bonds, then it can behave as bisexual ligand, right? अब d orbital वाला समझिए. For example, pr3, right? Phosphorus has 5 electrons, 3 electron is here in bonding. It has one lone pair. One lone pair हो गया. Phosphorus is back into 3d orbital, right? It means pr3 can also behave as bisexual ligand. So any ligand in which donor atom has one electron pair and either donor atom has back into d orbital or donor atom is bonded to multiple bonds, then such kind of ligand can behave as bisexual ligand. Is it clear? For pi bonding, what is the requirement? Yeah, pi donor ligand, what is the requirement? Listen, first bond, that is sigma bond, formed by ligand. That means for formation of sigma bond, it will have one electron pair. For sigma bond, one electron pair. Pi donor ligand also donate electron for pi bonding. That means another extra electron pair is also required for any ligand to behave as pi donor ligand. It means any ligand in which donor atom had at least two electron pair, right? One electron for sigma bonding, other electron for pi bonding, because pi donor ligand form pi bond via donating its electron pair to the vacant orbital of the metal. It means this ligand or this donor atom have at least how much? Two electron pair. जितने भी ligand हमने यहाँ पे लिखे हैं, all these ligands have, in all these ligands donor atom have at least two electron pair, at least two, must है ये, right? For example, O2 minus, O2 minus is like this. What is the requirement? Requirement is for two electron pair. How much electron pair are there? 4. Br minus similarly 4. Cl minus similarly 4. OH minus में देखिए. OH minus में 2, 2, 2. How is there? 3 electron pair. हमें चाहिए कितना? 2. तो pi donor कैसे पहचानोगे? Any ligand in its donor atom has at least 2 electron pair can behave as pi donor. Any ligand in which donor atom has one lone pair and donor atom is either bonded to multiple bond or donor atom has d block, then it can behave as bisexual ligand. Clear? Is it clear?
So,
हाँ बोलिए.
Sir,
सर ये सेंट्रल मेटल एटम की टेंडेंसी के ऊपर डिपेंड नहीं करता.
नहीं, ये तो अलग बात है. मतलब इंडिविजुअल अगर आपसे कोई पूछे, इंडिविजुअल अगर आपसे कोई पूछे कि ये लिगेंड किस तरह काम करेगा, तो आप कैसे बताओगे? मतलब इंडिविजुअल अगर कोई लिगेंड
Okay.
है तो आप बताना ना, उसके बाद तो बिहेवियर बदलेगा आपके बाद, ठीक है? राइट?
Okay.
sir, this carbonyl group has two pi anti-bonding orbitals. So it will accept in one of those because this lone pair is already in one of the pi ABMO. Then it will accept the other lone pair from metal, the two electron pair from metal in its.
हाँ, ओके, प्लीज गो
हाँ
अहेड.
सर, जैसे देखिए पाई एक्सेप्टर लिगेंड्स जो होते हैं, आपने बोला कि अगर उसके पास या तो पाई स्टार ऑर्बिटल हो उसमें ले लेगा या वेकेंट डी ऑर्बिटल में ले लेगा. इन केस ऑफ सीओ वहाँ पे तो वेकेंट डी ऑर्बिटल नहीं है, बट वी हैव अ पाई स्टार एबीएमओ एम्प्टी बिकॉज वन ऑफ द पाई एबीएमओ इज फिल्ड विद दिस लोन पेयर. दिस व्हाट
This lone pair is not present in pi anymore, right?
एनबीएमओ, सॉरी नॉन बॉन्डिंग में.
हाँ, नॉन बॉन्डिंग, बिल्कुल.
ओके सर, माय क्वेश्चन इज समथिंग एल्स. अगर ये इलेक्ट्रॉन लेता है और एबीएमओ में जाता है तो दिस विल डीस्टेब, मतलब इसका बॉन्ड ऑर्डर को डिक्रीज कर देगा. तो व्हाट इज द ड्राइविंग फोर्स फॉर व्हिच इट इज डूइंग समथिंग व्हिच विल डीस्टेबलाइज इट?
Good. Listen, this is the metal, right? Before we are going to donate electron in metal, this is formation of metal carbon bond, right? The donation of a non-bonding orbital of the carbon, that is the HOMO, the vacant orbital of metal, and formation of sigma bond, right? This is the CO. Now metal is going to donate electron into the vacant orbital, that is pi star. So this will lead to weakening of this carbon oxygen bond, right?
Yes sir.
But this will also lead to the formation of metal carbon bond too, ना? ये वीक तो हो रहा है, लेकिन मेटल कार्बन बॉन्ड भी तो बनेगा जब इधर से सिग्मा बॉन्ड हो गया, राइट? बट डोनेशन ऑफ इलेक्ट्रॉन क्लाउड ऑफ मेटल टू द कार्बन ऑल्सो लीड्स टू फॉर्मेशन ऑफ मेटल कार्बन पाई बॉन्ड। तो जो यहाँ वीकनिंग हो रही है ना, वो यहाँ से बैलेंस भी तो होगी।
तो ये
कार्बन
सर
और
मेटल,
बॉन्ड
सर ये मेटल कार्बन के बीच में सिग्मा बॉन्ड बनेगा या पाई बॉन्ड?
ना सिग्मा बॉन्ड, सिग्मा बॉन्ड जो है, सिग्मा बॉन्ड तो पहले बनेगा क्योंकि कार्बन जो है फर्स्टली फॉर्म सिग्मा बॉन्ड बाय नॉन बॉन्डिंग इलेक्ट्रॉन। व्हेन मेटल डोनेट्स इस इलेक्ट्रॉन to the vacant orbital, that is the pi star orbital of carbon monoxide, then there is also the formation of metal carbon monoxide. First sigma bond is formed by what? Donation of electron from carbon to metal. Pi bond is formed by donation of electron from metal to the carbon. तो सिग्मा तो ऐसे बन गया, पाई यहाँ से बनेगा जब डोनेट करेगा तो when metal is when metal is donating electron to the pi star of the carbon monoxide, then yes, there is weakening of carbon oxygen bond, but also there is formation of metal carbon bond too, right? तो एक तरफ कमजोर तो हो रहा है लेकिन एक एक्स्ट्रा बॉन्ड भी तो बन रहा है ना। ओके,
यस सर,
ओके फाइन। और एक चीज सुनिए, जरूरी भी है, क्यों जरूरी है? लिसन, कार्बन, the electron pair which is given by carbon to the metal is basically reside in non-bonding molecular orbital, right? Non-bonding orbital is basically located on the carbon. Non-bonding molecular orbital is mainly located on the carbon atom. That is why when carbon is donating electron to the metal, then there will be partial positive on the carbon, right? In order to balance this partial positive charge, metal is going to donate electron cloud, right? तो एक फायदा तो ये भी होना कि जो कार्बन का पार्शियल पॉजिटिव है, that is also neutralized by donation of electron cloud from metal to the carbon. This is also a kind of driving force, because in any system, if there is positive charge or negative charge system, then energy of such molecule is very high. If via any process you are going to reduce charge on any system, then it will lead to increase in stability of complex. तो ये डोनेशन से ये न्यूट्रलाइज भी होगा, तो वो भी एक तरह का गेन ही है एनर्जी में, राइट?
यस सर। एंड दिस, आपने बोला सर ये जो NBMO है दैट्स विल लाई क्लोज टू कार्बन, दिस इज बिकॉज ऑक्सीजन इज अ इलेक्ट्रोनेगेटिव एटम, तो उसका एटॉमिक ऑर्बिटल्स का स्टेबिलिटी विल बी मतलब हाई, तो उसका एनर्जी लेवल विल बी लो, एंड कार्बन के लिए वो हाई रहेगा, तो NBMO का एनर्जी लेवल विल बी कोरिस्पोंडिंग टू कार्बन का एटॉमिक
हाँ बिल्कुल,
एटॉमिक।
एग्जैक्टली, बिल्कुल बिल्कुल बिल्कुल। एक्चुअली this can be explained by the molecular orbital, the non-bonding orbital on which atom will be मतलब either carbon or oxygen, but yes, in this case what you are telling is true, but it's not in case of मतलब every molecule is not the same case, but in carbon also it is same. हाँ, yes, the non-bonding molecular orbital, which is high energy orbital, is basically located on carbon, this high energy electron, as compared to oxygen, which orbitals are of low energy because of more nuclear force, that is more electronity of the oxygen. That's why carbon is donating electron pair, and HOMO is basically located on the carbon. That is why electron is, in case of carbon monoxide, electron is given by carbon, not by oxygen. It means bonding of carbon monoxide like this is correct, but bonding of carbon monoxide like this is incorrect, right? ये केस में पूछा गया है, ठीक है? Why this kind of bonding for carbon monoxide feasible, and this kind of bonding for carbon monoxide not feasible? So you can explain it by explaining molecular orbital diagram, suggesting that the HOMO, that is the highest occupied molecular orbital, is a non-bonding of character, and that orbital is localized on the carbon. Therefore, electron is donated by carbon, not by oxygen. Right?
ओके सर,
ये क्लियर?
Yes, sir.
ठीक है, आगे चलें?
Sir, a request.
हाँ हाँ बोलिए।
Sir, the audio is little bit not so clear, sir. Like it's some noise is coming behind whenever you are
Okay.
speaking.
अच्छा अच्छा अच्छा।
yes sir, whenever you speak there is the noise is coming, like whenever you speak the noise comes, and when you don't speak the noise is goes, so I think there is some issue with your
हाँ
the ear.
माइक, हाँ बिल्कुल बिल्कुल, आई थिंक देखता हूँ मैं इसको सही कर लूंगा मैं 2 दिन में, ठीक? अभी तो ये चेंज कर लेता हूँ, इसको चेंज कर दूंगा मैं। तो अभी देखते हैं, थोड़ा
Also-
मैनेज करेंगे, फिर कुछ करते हैं।
And sir, one
sir,
more
और
request.
ये बताइए तो
Voice-
आपको समझ में आ रहा है कि नहीं?
And the voice
also
is
the
like
voice गूंज
you are
रहा है
like
sir,
it's
echoing, empty room probably.
हाँ एग्जैक्टली, बिल्कुल 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 बिल्कुल, वो रूम भरा नहीं है
Echoing, sir.
इसीलिए। ठीक है, मैं कर लेता हूँ, उसको ठीक कर लूंगा मैं। ठीक है, कल तक देखता हूँ मैं। एक माइक मेरे पास दूसरा है, मैं कनेक्ट कर लूंगा उसको, देखता हूँ अगर हो जाता है उससे तो। ठीक है,
Okay sir.
हाँ मैं कल कर लूंगा वो। ठीक है, अभी थोड़ा मैनेज कर लीजिए, बट कल मैं कर लूंगा उसको, देख लेता हूँ उसको कनेक्ट करके। एक्चुअली काम नहीं कर रहा था तो मैंने उसको लगाया नहीं। चलें भाई, चलिए मैं थोड़ा कोशिश करता हूँ स्लो बोलने की, तो शायद हो सकता है ठीक लगे। ठीक है, थोड़ा इसको दूर कर देता हूँ मैं, तो वो एम्प्टी रूम है ना, इस वजह से थोड़ा होता है उसका। ठीक है, तो हम लोग कहाँ पे थे, राइट? अब वन मोर थिंग, it means d block metal can be into oxidation state. Low oxidation state, right? Then what kind of ligand are required? Pi acceptor ligands, right? Because metal is electron rich, then it will require those kind of ligands which have capacity to accept extra electron pair, that is increased electron pair, that is high electron density of metal, so that metal can remove its high electron density and get stable. Similarly, if metals are present in high oxidation state, right, then it requires, it will prefer to bind to those ligands which have electron cloud, that is at least 2 electron pairs, so that they can behave as pi donor. So in such cases, they prefer to bind with pi donor ligands. Is it clear? Low oxidation state metal prefer to bind with pi acceptor ligand, and when metals are present in high oxidation state, they prefer to bind with pi donor ligand. Is it clear?
Yes, sir.
Okay. Pi acceptor ligands are CO, NO, right? And from there, from this kind of bonding, there is new kind of chemistry or new kind of complexes which are called metal carbonyls, right? Where metal present in low oxidation state and it binds with CO, that is a pi acceptor ligand. तो पहले आपको ये समझना जरूरी है कि मेटल कार्बोनिल्स कहाँ से आया। तो metal carbonyls are those complexes in which metals are present in low oxidation state, and metals are bind with carbonyl ligand. Why carbonyl ligand? Because carbonyl ligand is pi acceptor, and when ligands are pi acceptor, then they will prefer to bind, or they bind with those metals which are where metals are present in low oxidation state. Right? Examples of these kind of complexes are, these are the oxides, right? Halides. For halides example, this is the most common compound, most important compound, I2Cl8 2 minus, right? Have you heard about this? This is the first complex which have delta bonding. This is the first complex with delta bond. Also asked in UPSC 2, right? ये भी पूछा गया है एग्जाम में। ठीक है, तो मेटल कार्बोनिल similarly, when metal bind with nitrosyl ligand, then another kind of complex that is called metal nitrosyl, right? चलिए, अब first we are going to study metal carbonyls. Metal plus complexes in which there is metal present along with carbonyl ligand. Bonding देख लेते हैं, bonding in metal carbonyl. Two bonds, sigma bond and pi bond, right? The first formation of sigma bond. Always remember that sigma bond is always formed by the ligand, not by metal, right? Because each ligand, any group or any chemical species can behave as ligand only when it has capacity to donate at least one electron pair to the metal, and that electron pair firstly will form sigma bond, if it has 2 electron pair, 3 electron pair, then it can also form pi bond. But each ligand, चाहे वो सिग्मा डोनर हो, पाई एक्सेप्टर हो, कोई भी हो, वो सिग्मा बॉन्ड जरूर बनाएगा. ठीक है. So that means sigma bond is already formed by donation of electron, yeah, always formed by donation of electron from ligand to metal. The formation of sigma bond. So for this, metal should have what? Vacant orbital. Vacant orbital. Either like this, either like this, right? Plus ligand has electron pair. Which combination is correct? First one or second one? For sigma bonding.
Second one, sir.
Second, right? This is not correct because sigma bond is formed along the axis, right? Along the axis ये है, हाँ, right? Internuclear axis. तो ये तो बनेगा नहीं, मतलब मैंने समझाने के लिए बोला ही, like this. जैसे the vacant ये लिख देंगे, तो vacant orbital on metal, vacant orbital on metal. This is the filled orbital on ligand, that is NBMO, filled orbital on ligand. Vacant orbital, but carbon monoxide lone pair. Further, like this, this is the sigma bond. कैसे बना है? Donation of electron from CO to metal. This na? Metal. Yes. Actually, these kind of orbitals are basically hybridized orbital, right? Okay. Hybridized orbital that lie along the internuclear axis, right? Mm-hmm. Not needed square. In most of the cases, it is said that because one thing is clear, na? Okay. If there is possibility of hybridization, then each metal undergo hybridization because hybrid orbital has more electron density. Also, they have better overlapping capacity as compared to pure s orbital, p orbital, and d orbital. Then each metal try to go hybridization and try to undergo hybridization so that it can form a stronger bond, right? Not dz squared. It is said that these are the hybridized orbital, mixing of s and d, dz square, or mixing of s and p, right? Multiple combination is possible for orbitals which lie along the axis, right?
Okay, sir.
Next, second, the formation of pi bond. Formation of pi bond, right? For pi bond, because ligand is pi acceptor, so pi bond form between the axis, right?
Yes, sir.
Yeah, beyond the internuclear axis. This is the filled d orbital on metal. Why not hybrid orbital? I have written here filled d orbital, not hybrid orbital. Why?
Yes, sir. Because a hybrid orbital are involved in the sigma bonding.
Because hybrid orbital cannot form pi bond because in hybrid orbital one lobe is larger, other lobe is smaller. But for pi bonding there is sidewise overlap. If you are going to make pi bond with hybrid orbital, then these bond will be very big because pi bond is formed by sidewise overlap, right? Like this, like this. But if such kind of orbital is going to form pi bond, then this overlapping is effective, but this overlapping is minimal, negligible. Listen, pi bond is weak bond because overlapping is of sidewise type. If sidewise overlapping is also reduced, where in cases of like this, then this bond will be very weak.
Efficient
So,
overlap.
then such kind of bonding doesn't exist, right? If such kind of bonding in complexes, like in the case of benzene exists, then such kind of molecule will be highly reactive, highly unstable. But that is why in most of the cases or majority of the complexes, hybrid orbitals do not involve in pi bonding because one lobe is larger that can have effective overlapping, but other lobe is so much smaller that side-wise overlapping will be very, very weak, which is the basis or which is the process for the formation of pi bonding. That is why we have, during the formation of pi bond, we never take the hybrid orbital. We always take either p orbital or d orbital or f orbital, right? Now, is it clear now? Yes,
Yes,
is it
sir.
clear?
So,
So, carbon monoxide to the backend pi star, right? Like this. This is the backend pi star, either pi star 2pz or 2px, 2py, whatever name you want. So, backend pi star orbital. There, donation of electrons from metal to backend orbital. We can like this. Yes, दिखा सकते हैं हम लोग like this, right? Pi in pi star orbital, pi star is similar to that of d orbital. That is why opposite lobes has same sign, same sign, same sign. Similar here, d orbital opposite lobes है same sign is the same. तो आपको exactly ऐसे ही draw करना है, ठीक है? Exam में you have to draw pi star orbital only like this and d orbital like this, not in other way. Is it clear? Because pi star orbital looks like this and d orbital looks like this, right? Is it clear now?
yes, sir.
Yes, sir.
Overlapping दिखा देते हैं, तो ये बन जाएगा. This is the CO what pi bond, right? Finally दोनों को मिक्स कर सकते हैं हम लोग, तो क्या बन जाएगा? Metal P double bond O to the sigma bond. This is the pi bond. This is the bonding in metal carbonyls, right? Bonding in metal carbonyl has some reactivity effect on the carbon monoxide, right? Let us see. Carbon monoxide in individual state is donor, that is base, right? Donor atom is what? Donor atom is carbon, that is, this is the nucleophilic center, right?
Yes, sir.
Individual state, nucleophilic center. When carbon monoxide bond with metal, that is in case of metal carbonyl, then this will become electrophilic center, and oxygen become nucleophilic center. This is called ampolon. You have heard in organic chemistry ampolon, nucleophilic center. How this happens? Listen. During donation of electron from carbon to oxygen, this is the non-bonding electron. So, donation of electron from carbon monoxide to metal is mainly donated by the carbon atom. That is why carbon adopt partial positive, right? When metal donate electron to the pi star orbital, then electron density comes on both carbon atom as well as oxygen atom, because metal is donating electron into the pi star, and pi star orbital is present on both carbon and oxygen. It means when carbon monoxide donate electron to the metal, electron is mainly donated by that orbital which is largely localized on carbon, because this orbital is of non-bonding type, and non-bonding orbitals are similar to that of atomic orbitals. That means they mostly present on one atom, either carbon or oxygen, right? But donation of electron from metal to ligand is in pi star orbital, which is molecular orbital, which is present on both carbon and oxygen, due to which when metal donate electron to the carbon, this positive charge is neutralized, but not fully neutralized, because metal is donating electron to such orbital which is present on both carbon and oxygen. That means electron will be distributed on both carbon and oxygen. That means electron is given only by the carbon, but electron is accepted by both carbon and oxygen. That means this positive charge is not completely satisfied or neutralized. That means this carbon center has remaining partial positive. That is, this carbon center remains electron deficient. That is why it behaves as electrophilic center. Is it clear?
sir.
डोनेशन सिर्फ कार्बन ने किया, बट एक्सेप्टेंस पाई स्टार में हुआ, दैट इज प्रेजेंट ऑन बोथ कार्बन एंड ऑक्सीजन, राइट? अब ड्यूरिंग डोनेशन इलेक्ट्रॉन इज टेकन बाय बोथ कार्बन और ऑक्सीजन. ड्यूरिंग डोनेशन कार्बन is involved in donation of electron to metal, but during acceptance electron is taken by both carbon and oxygen. That is why this bill has increased electron density. Why increased electron density? Because donation के टाइम पे तो कार्बन ने डोनेट किया, बट ड्यूरिंग एक्सेप्टेंस ऑफ इलेक्ट्रॉन इज टेकन बाय बोथ कार्बन और ऑक्सीजन. मतलब ऑक्सीजन ने इलेक्ट्रॉन दिया नहीं है, लेकिन जब पाई स्टार में आता है देन ऑक्सीजन को इलेक्ट्रॉन मिल रहा है. इसका मतलब क्या हो जाएगा? इंक्रीज्ड इलेक्ट्रॉन डेंसिटी, hence it will have as nucleophilic center. Is it clear?
Yes, sir.
इफेक्ट देखिए देखिए, जैसे मान लीजिए M डबल बॉन्ड C डबल बॉन्ड O, if nucleophile, then this will attack on carbon. If there is electrophile E plus, then oxygen will attack on this, right?
Yes, sir.
न्यूक्लियोफाइल कहाँ अटैक करेगा? कार्बन पे. इलेक्ट्रोफाइल होगा तो यहाँ, फॉर एग्जांपल MCO, छोटा सा एग्जांपल लेता हूँ आपको समझाने के लिए. M plus AlCl3. AlCl3 what? Lewis acid, right? This is Lewis acid. Then what will be formed?
Fusion center.
MCOAlCl3. ऑक्सीजन बाइंड करेगा, राइट?
Yes, sir.
इट इज करेक्ट. अब अगर इसको ऐसे कर देते हैं, ये भी इनकरेक्ट है. अगर आप इसको ऐसे कर देते हैं तो भी इनकरेक्ट, राइट? सिमिलरली M double bond C double bond O, OH minus, it is nucleophile, then it will attack here. M double bond C, इसको ऐसे कर देते हैं, O minus OH, right? तो behavior of carbon monoxide itself changed when carbon monoxide undergo bond formation with metal carbonyl. In free state, carbon of the carbonyl ligand behave as nucleophile, right? However, in case of metal carbonyl, the carbon of the carbon monoxide behave as electrophile, that is electrophilic center, while oxygen of the carbon monoxide behave as nucleophilic center, right? Is it clear?
Yes, sir.
इस इंटरेक्शन को, ये जो बॉन्डिंग हो रही है, इसको
हम्म।
आप मॉलिक्यूलर ऑर्बिटल के ओवरलैप से दिखा सकते हैं क्या दोनों के लिए?
कौन सी बॉन्डिंग?
सर ये जो MCO से AlCl3 हो रहा है, Al का तो
हाँ,
p ऑर्बिटल.
बिल्कुल 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 देख सकते हैं
सर
आप. हेलो,
सर
हाँ जी बोलिए.
सर ये मेटल से जो कार्बन के ऊपर पाई बॉन्ड बन रहा है, उसमें सर T2G ऑर्बिटल पार्टिसिपेट कर रहा है ना?
बिल्कुल बिल्कुल बिल्कुल
ओके
बिल्कुल. डी ऑर्बिटल है, वही तो T2G बनाएंगे ना. because T2G orbital are those lie between the axis, and d orbital like what? They said dxy, right? dyz, dxz, they lies between the axis, है ना, between the axis, और यही आपस में क्या मिलती बनाती है T2G। ठीक है, अब T2G लेकिन आप तब बोलोगे जब ऑक्टाहेड्रल होगा, इसलिए मैंने कोई टर्म यूज नहीं किया वहां पे, बिकॉज I am not talking about octahedral complex, tetrahedral complex, square planar, TGP. I'm just talking about bonding between metal carbonyl, not any particular geometry. But if it is octahedral complex, then these orbitals which are going to form pi bond with carbonyl, then these are the T2G, right?
सर ये जो हम टी और ई का जो कॉन्सेप्ट
ठीक है
होता
ना?
है ये क्रिस्टल फील्ड थ्योरी के हिसाब से लगाते हैं ना,
किसको? हाँ
मतलब
बिल्कुल
ये जो
बिल्कुल, एक्चुअली लिसन, क्रिस्टल फील्ड थियरी is just a beginning, right? T2G, EG, these comes from the group theory. So crystal field theory is a minor application of these. In case of molecular orbital theory, we also going to form basically symmetry concept है। अब when we after crystal field theory, after failure of crystal field theory, because there is a lot of properties of coordination complexes is not explained by crystal field theory, we move to the molecular orbital. In molecular orbital theory, we also going to symmetry symbol like P2G, EG, A1G, A2U, A2U, right? तो ये broad application है, group theory का part है।
ओके
Minor application है CFT में, right?
यस
Okay. आगे चलें?
सर मॉलिक्यूलर ऑर्बिटल
हाँ
ओवरलैप दिखा दीजिए एक बार सर, वहीं पे दिखा देते अगर जगह तो थोड़ा
हाँ, ठीक है
साथ
ठीक
में
है ठीक है,
रिलेटेड।
ओके ओके ठीक है। देखिए पहले थोड़ा बताना पड़ेगा ना LCl3 के बारे में आपको, एक्चुअली चलो यही बता देते हैं, यही बता देते हैं, ठीक है, या यही बता देते हैं। MCO is the lone pair filled orbital, AlCl3 ऐसे दिखाइएगा फिर ऐसे, राइट? Cl 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 backend orbital, this is the backend p orbital, right? backend p orbital, इसके बाद भी क्या होगा? filled p orbital, बॉन्डिंग हो, ठीक है, ओवरलैप दिखा दो, ऐसे दिखा दो तो डायरेक्टली किसकी AlCl3 backend p orbital and oxygen is oxygen is filled p orbital, and there is donation of electron from the filled orbital of oxygen, चाहो तो 2p लिख सकते हो नाम, यहाँ पे यहाँ क्या लिख सकते हो 3p, राइट? इसको प्लानर बनाइएगा लेकिन AlCl3 को, ठीक है?
यस सर। सर मतलब इसमें ये जो जितने भी इंटरेक्शंस हुए इसमें इनिशियली कार्बन मेटल के साथ सिग्मा बॉन्ड बनाया थ्रू NBMO,
बिल्कुल,
और फिर सर एक्सेप्ट किया पाई स्टार में, और फिर जब ये AlCl3 के साथ बॉन्ड बना रहा है तो ऑक्सीजन अपना p ऑर्बिटल यूज कर रहा है।
अब देखो इसको इन मॉलिक्यूलर टर्म यू कैन आल्सो नेम इज मॉलिक्यूलर ऑर्बिटल, राइट? बट लिसन वन थिंग, orbitals, molecular orbitals, what is the concept? Those orbitals which are closer, इमोजी समझाना पड़ेगा फिर आपको इसके लिए, देखो मैंने क्यों लिख दिया यहाँ पर सिंपली ऐसे, जो भी ऑर्बिटल मेटल के ज्यादा क्लोजर होती है या जिस भी एटम के ज्यादा क्लोजर होती है, either high energy orbital or low energy orbital, that orbital has character similar to that of atomic orbital of that orbital।
यस सर, वो एनर्जी
जैसे
का गैप कम रहता है।
हाँ एग्जैक्टली वो ज्यादा कुछ फर्क होता नहीं है उसमें, तो बिहेवियर लगभग सिमिलर होता है, राइट? तो अगर हम चाहें तो इसको मॉलिक्यूलर ऑर्बिटल से दिखा सकते हैं कि जो ऑक्सीजन में जो हाईएस्ट एनर्जी ऑर्बिटल होगी, ऑक्सीजन पे जो हाईएस्ट एनर्जी ऑक्यूपाइड ऑर्बिटल होगी, वो ऑर्बिटल का जो फील्ड इलेक्ट्रॉन पेयर होगा उससे ओवरलैप कर लेगा। बट उसका इंपॉर्टेंट क्या है? इंपॉर्टेंट है शेप, उसका शेप सिमिलर किसी तरह से होगा, क्योंकि अगर इस तरह से नहीं होगा तो बॉन्ड ही नहीं बनेगा। दैट इज जो शेप होगा या सिमेट्री होगी या ज्योमेट्री होगी डोनर ऑर्बिटल की, दैट इज lying upon the oxygen, that will be similar to that of backend p orbital, because if it is not similar, symmetry in size, symmetry mostly size dissimilar हो सकता है, then there will be no such kind of bonding between MCO and AlCl3, right?
यस
आगे चलें?
यस सर।
और ये अभी हमने यहाँ पे 2p से बताया है, आगे मैं आपको पढ़ाऊंगा एमओ डायग्राम, तो आपको मैं आइडिया दे दूंगा कि कौन सी ऑर्बिटल इंटरेक्ट करना चाहिए, ठीक है। बट वन थिंग इज क्लियर, bonding between two species, molecule, atom, या bonding between two molecule is possible only when interacting orbital on both species should be of same symmetry, right? Symmetry is not clear, then there will be no bonding, because same symmetry अगर नहीं है तो डायरेक्शन ओरिएंटेशन डिफरेंट होगा, डायरेक्शन डिफरेंट होगा, तो बॉन्ड तो बनेगा ही नहीं, राइट?
सर सर ये एमओ के हिसाब से जो नॉन बॉन्डिंग हम लोग दिखा रहे हैं, ये एसपीजेड है ना, ये कार्बन का?
एग्जैक्टली, हाँ एसपीजेड है, बिल्कुल बिल्कुल एसपीजेड है। कुल्सन मॉडल एक्चुअली अभी मॉडर्न मॉडल भी एक आया है, मॉडर्न मॉडल के अकॉर्डिंग the highest molecular orbital that is present on carbon is of anti-bonding type, but according to Coulson model, which is widely accepted in most of the books and also uh, most of the universities or IITs, it is the Coulson model that is most popular. According to Coulson model, the electron present at the carbon, that is non-bonding electron, is present in sp orbital, which is largely localized in the carbon, right?
Yes, sir.
That is why it is in many exams, it is commonly asked question is that what is the nature of the home of the carbon monoxide? So it is the non-bonding that is largely localized in the carbon, right? And it is one of the reason that during bonding of carbon monoxide, it is the carbon which firstly bind with any metal as compared to oxygen, because HOMO is largely localized in the carbon, which is of non-bonding type, right?
Yes, sir.
आगे चलें?
Yes, sir.
Okay. इफेक्ट देख लेते हैं। बॉन्ड ऑर्डर effect on carbon monoxide on bonding with metal, right? When metal carbonyl undergo bonding with carbon monoxide, neutral carbon monoxide is bond order of 3, right? Bond order was 3. When metal donates electron to the vacant pi star of carbon monoxide, then bond order of carbon monoxide is reduced. So what? Reduction in reduction, decrease in stretching frequency of decrease in mu CO, right? Due to increase in electron density, in pi star, right? So
Yes, sir.
it means nu CO free is greater than nu CO in metal carbonyl. Is it clear? That means
Sir.
carbonyl stretching frequency is more in free carbonyl as compared to carbonyl present in metal carbonyl. And if CO is converted to CO plus, then it has bond order of 3.5, right?
Sir.
Okay? Then new CO plus has AX के लिए CO plus के लिए, तो ये ऑर्डर थोड़ा ध्यान रखना आपके। But one thing you have to remember, this is not always true. For this is not always true, right? In some complexes, where metals are present in high oxidation state. Metals are present in high oxidation state, then new MCO is greater than new CO, right? And such metal carbonyls are called non-classical metal carbonyl. Non-classical, जैसे ऑर्गेनिक में क्लासिकल नॉन क्लासिकल कार्बोकेटायन होता है, नॉन क्लासिकल मेटल कार्बोनिल। आगे बताऊंगा मैं आपको, ठीक है? जैसे फॉर एग्जांपल एक आपको बता देता हूँ। फॉर एग्जांपल कॉम्प्लेक्स है IrCO6 3+, it has more stretching frequency value of carbon monoxide as compared to free carbon. इससे ज्यादा नहीं होता, बट इससे ज्यादा होता है, राइट?
सर वो पहला वाला सर पहला वाला क्या है, CO वाला?
CO प्लस के लिए
CO
है।
प्लस है।
हाँ, CO प्लस है। इस 3.5 बॉन्ड ऑर्डर, राइट? इधर 3 बॉन्ड ऑर्डर। क्लासिकल वाले में इट इज बिटवीन 2 to 3, तो मतलब 3 से कम है और 2 से ज्यादा है, तो इन सबसे तो 3 हो गया, राइट?
सर
इस पे बहुत सारे क्वेश्चन आते हैं, आगे पढ़ाएंगे हम आपको ठीक से आराम से। हाँ जी, बोलिए।
सर इसको स्ट्रेचिंग फ्रीक्वेंसी से क्यों डिनोट करते हैं?
ये एक्चुअली बॉन्ड जो होता है ना, बॉन्ड ऐसे वाइब्रेट करता रहता है ऑलवेज, ठीक है? ये ऐसे फ्लक्चुएट करता रहता है। अभी जितना ज्यादा स्ट्रॉन्गर होगा, इसको स्ट्रेच करने के लिए उतनी ही फ्रीक्वेंसी की जरूरत पड़ेगी। अब समझिए, स्ट्रॉन्गर बॉन्ड will have more bond energy, right?
यस सर।
It means more energy will be required in order to either increase in bond length or decrease in bond length of such kind of bond.
यस सर।
More energy means more frequency, because energy directly proportional to frequency ना,
यस
equal
सर,
to h
मतलब
nu होता है ना, equal to h nu, right?
यस सर।
So whatever the strength of this kind of bond is there, more energy will be required to stretch such kind of bond. That means more frequency will required, या more energy will required, that means more frequency will required to stretch such kind of bond. That means अब एनर्जी अगर इसकी ज्यादा है, तो इसको स्ट्रेच करने वाली फ्रीक्वेंसी भी क्या होगी, ज्यादा होगी। It means bond strength can be directly measured in term of frequency.
यस सर। सर मतलब बॉन्ड ऑर्डर इज डायरेक्टली प्रोपोर्शनल टू स्ट्रेचिंग फ्रीक्वेंसी।
Exactly, बिल्कुल बिल्कुल बिल्कुल, right? Stronger the bond order, मतलब more the bond order, larger the bond length, that will be related to the stretching frequency, that is IR, right?
यस सर।
IR frequency, that is infrared spectroscopy हम लोग पढ़ते हैं, ठीक है?
यस सर।
ठीक है, तो हम लोग अब नेक्स्ट क्लास में पढ़े, डेमो था मतलब, उसके बाद तो प्रॉपर टॉप हम पढ़ाएंगे इसके बाद, ठीक है? If there is any kind of doubt, then you can ask me.
No, sir.
Okay, नाइट्रोसिल भी पढ़ा दे क्या अभी? चलो बता देते हैं, है ना? देख लेते हैं नाइट्रोसिल भी। चलिए, मेटल नाइट्रोसिल सुपरफिशियली देखिए, बाकी पढ़ाएंगे तो मेटल नाइट्रोसिल, राइट? फर्स्ट NO लिगैंड, राइट? बॉन्ड ऑर्डर इज व्हाट? 2.5, N डबल बॉन्ड O, राइट? NO इज दिस, ठीक है? और ये डॉटेड से क्यों दिखाया मैंने? बिकॉज ऑफ 2.5. It can accept one electron to get converted into NO minus. It can release one electron to get converted into NO plus. Nitrosyl anion, nitrosyl cation. It also has one unpaired electron, which is present in more anti-bonding orbital. ठीक है? तो anti-bonding orbital has one electron. If it accepts one electron, then it will also go to anti-bonding orbital, and leading to decrease in bond order, that is 2.5 to 2.0. If electron is removed from NO, then electron will be relieved or removed from the anti-bonding orbital. That means increase in bond order. Then here will be bond order 3.0. Right? This is the ABMO. If we will put one electron in anti-bonding orbital, then bond order will be reduced by 0.5. Right? That is why on going from NO to NO minus, bond order decreases from 2.5 to 2.0. If we are going to remove one electron from ABMO, then bond order will increase by 0.5 unit. That is why on going from NO to NO plus, bond order increases from 2.5 to 3.0. Right? Here we can like this, one lone pair and one lone pair. Right? One lone pair is this one electron in this orbital, one lone pair, the two lone pair. This is the NO minus. Right? NO plus, bond order 3 is the lone pair. The plus 3 minus, right? So in ionic state, NO can adopt two structure or two type of two structure. One is the NO minus, where bond order of NO is 2.0. Another is NO plus, where bond order of NO is 3.0. Right? Is it clear? Is it clear?
Yes, sir.
Okay. Now, bonding in metal nitrosyl. Similarly, pi-acceptor ligand, when nitrosyl is also pi-acceptor ligand, then there will be formation of sigma bond, the formation of pi bond, right? So NO has two type of bonding mode, right? One is the linear mode. Why linear? Why bent? This will be also clear sometime. Linear, another is bent, right? First linear mode. Linear. यही कहते हैं. अब NO minus is like this, and NO plus is like this. According to you, which NO, either NO minus or NO plus, can undergo linear kind of bonding?
NO plus.
NO plus, right? Because this orbital is present along the axis, right? Nitrogen, oxygen lone pair in same axis. Here, nitrogen, oxygen is same axis, but donor lone pair is on different axis. That means it can bind in linear mode, right? And this can bind in bent mode, either from here metal, either from here, right? Clear, na? Is it clear?
Sir,
हाँ.
Yes, sir.
Okay. किसी को डाउट हो तो बोलो. चलिए इसमें आता है लीनियर. तो लीनियर मोड ऑफ बाइंडिंग, लीनियर मोड, सिग्मा बॉन्डिंग, metal as vacant orbital along the axis, NO plus lone pair, that is HOMO, the vacant orbital, filled orbital, M overlapping, that is the formation of sigma bond between metal and pi bonding. Metal has filled orbital, filled d orbital, plus pi acceptor, right? अभी मैंने बताया था ना कि any ligand which have in which donor atom has one lone pair and donor atom is bonded to multiple bonds, and it can behave as pi-acceptor ligand, any ligand, right? This is the vacant pi star, vacant pi star. इसे तो नहीं दिखा सकते, like this, and overlapping like this, like this. This is the formation of pi bond. M and O. This is the pi bond. This is sigma bond. See how much electron is donated by NO to metal? Can you tell me? How much electron in linear mode NO is giving to any metal center? 2 electron, 4 electron, 3 electron. How much electron?
2.
2. It means in linear mode 2 electron is donated by NO to metal, right? Where NO is present as, or one more thing, NO कब? When NO is present in ionic state, right? Not in neutral phase. ionic state समझ रहे हैं ना? क्योंकि हमने NO को NO plus माना है यहाँ पर, NO को neutral नहीं माना है, right? It means in ionic state and linear mode, दोनों चीजें लिखना है आपको. Ionic state and linear mode, NO gives 2 electron to the metal. Is it clear?
Sir,
सर लीनियर मोड में सिग्मा बॉन्डिंग पाई बॉन्डिंग दोनों आता है.
हाँ बिल्कुल होगा, क्योंकि along
Sir-
the axis है ना.
ओके सर. सर लेकिन प्रीवियस स्लाइड में शायद आपने सर लीनियर मोड और बेंट मोड बताया था, तो बेंट वाला तो पाई बॉन्डिंग हो गया, उसमें
नहीं
डिफरेंशिएट हो
वो भी सिग्मा हो जाएगा. क्यों नहीं होगा? सिग्मा वो भी हो जाएगा. देखिए कैसे.
जाएगा. प्रीवियस स्लाइड एक बार कीजिए.
हाँ बिल्कुल बिल्कुल. हमने सिर्फ बॉन्ड दिखाया है बस. हमने कहा कि बेंट में this lone
हाँ.
pair can interact with metal, this lone pair can interact with metal, like this.
तो सर यहाँ मतलब इट अपीयर, मतलब मेरे को यहाँ पे ऐसा लगा कि लीनियर मोड और बेंट मोड दो अलग चीजें हैं, और क्योंकि यहाँ
Actually
पे लीनियर मोड.
linear mode. Okay. Linear means metal, nitrogen and oxygen are on same axis, like this. This is the linear. It means linear मतलब there is 180 angle between metal, nitrogen and oxygen. Bent means and like this, or and like this. That is angle between metal, nitrogen and oxygen. Angle between metal, nitrogen and oxygen is less than 180. This means bent, means bent, right? ठीक है, ये मतलब है. Okay.
यस सर.
Similarly, in case of bent mode, यही समझा देता हूँ मैं. In case of bent mode, 2 electron either NO will bind with metal with this lone pair, or NO minus bind with metal with this lone pair. It means in this case, this is bent mode. It will also donate how much electron? 2 electrons. It means when NO is present in ionic state, then in linear mode, it gives 2 electron to the metal, and in bent mode, it also gives 2 electron to the metal, right? It means when we count 18 electron rule, or when we count number of metal bond, right? Or we are going to consider that in any complex, one NO is linear, one NO is bent. Then if we consider NO in ionic state, then in both cases, either linear mode or bent mode, electron donated by NO to the ligand, NO to the metal is 2. Ionic state में. Is it clear?
यस सर. तो यहाँ पे सर NO माइनस जो है ये बाइडेंटेट का काम नहीं कर रही है, मोनोडेंटेट ही है.
हाँ exactly, monodentate है. Exactly, monodentate. बाइडेंटेट ऐसे, और ये बाइडेंटेट नहीं होता इस तरह. बाइडेंटेट मीन्स होता है कि 2 डोनर एटम चाहिए. यहाँ तो डोनर एटम एक ही है ना. Bidentate mean ligands which are called bidentate when they are bind to metal via 2 donor atom, not by one donor
Yes, sir.
atom,
Yes,
right?
sir, yes, sir.
यहाँ तो सिंगल है. लीनियर मोड. हेलो.
यस सर यस.
ओके. इन न्यूट्रल, अभी हमने आयनिक स्टेट माना था, अभी न्यूट्रल स्टेट मान लेते हैं. न्यूट्रल स्टेट में लीनियर मोड. लिसन, any ligand can have two state, neutral and ionic, right? So NO, in case of ionic state, it can have two kind of adaptation. One is NO minus, one is NO plus. In both cases, that is linear and bent mode. NO in both linear mode and bent mode, donation capacity or donation of electron by NO to any ligand is 2. When NO is present in neutral state, that is there is no positive or negative charge, then NO can also bind in linear and bent mode, or in this case donation of electron capacity in linear and bent mode is different, right? Let us see linear mode. NO को हमने कैसे लिया है? NO plus, not NO minus, not NO plus, right? Linear mode. तो neutral NO है. तो neutral NO देखिए, neutral NO is like this. डॉट डॉट यहाँ लोन 1, यहाँ लोन पे, राइट? मेटल से बाइंडिंग करते हैं, ठीक है? तो सेकंड ऑर्बिटल, ये सिग्मा बॉन्ड वाला, these ऑर्बिटल will form pi bond, right? Yes. M N O, ये सेकंड ऑर्बिटल, सॉरी, filled orbital lone pair overlapping, and this orbital overlapping. This is the pi bond formation, and this is the sigma bond formation. This one, the sigma bond. How much electron is donated by ligand to metal?
Yeah.
How much?
4.
Oh,
No. 2
No,
this,
three.
1 this, 3.
3. Yeah.
3 electron donation,
Sigma down. So straight down.
right? ठीक है? तो लीनियर मोड में 3 इलेक्ट्रॉन डोनेशन हुआ. बेंट मोड and metal has two possibilities, either bind to this single one, either to this. That means metal can bind to those orbitals which has 1 paired electron, or metal can bind to those orbitals which have 2 electron pair. If we are giving to choice to any metal that you can bind only either this orbital or this orbital, and what do you think? Metal will prefer to bind with which orbital? Orbital which has single unpaired, that is 1 unpaired electron, or metal which has orbital which has 2 electrons? This, why?
Because it will bend. So there will be no proper
exactly.
overlapping.
Exactly. Actually, बिल्कुल, any species have a single unpaired electron. When any system or any orbital has 1 unpaired electron, then it is more reactive as
More
compared to orbital which are filled. That means this is the more reactive. So any metal which are coming to this Zeno system, then it will prefer to bind if it has choice, right? If it has choice, then it will prefer to bind to this, not this, right? ये less reactive है.
Sir, in this single electron वाला जो orbital रहेगा, this will always be perpendicular to the internuclear axis, because वो Z along
Actually,
the Z axis.
anti-bonding है. It is pi star, and pi star orbital means pi bond. Pi bond is always perpendicular to the internuclear axis, right?
Yes,
This
sir.
unpaired electron is present in pi star orbital of NO, and pi star orbital orientation of pi star orbital is like that of pi orbital, and pi orbital are present perpendicular to the internuclear axis. That is why I am drawing these orbitals perpendicular to the NO, right?
Yes.
So we can add like this. Sorry. O is a lone pair with the M. Electron donation is how much electron is donated by NO2 metal in bent mode?
1 electron.
1. Right? Means when NO is considered in nuclear state, then linear mode, then in linear mode, NO donate 3 electron to the metal. However, in bent mode, NO gives 2 electron to the metal, 1 electron to the metal. However, when we are taking NO in ionic state, then it will have two kind of adaptation, NO plus and NO minus. In both the cases, either NO plus, which is the linear mode, or linear mode, which is linear mode, NO plus, that means NO plus bind to metal in linear mode, and NO minus, which is which binds to metal in bent mode. In both the cases, NO give either NO plus or NO minus 2 electron to the metal. Is it clear?
Yes,
मतलब
sir.
न्यूट्रल में दो पॉसिबिलिटीज है 3 and 1, but in case of ionic, NO plus NO minus both give 2 electron,
Well,
right?
सर पता कैसे चलेगा कौन सा मोड में हो रहा है बॉन्डिंग?
दोनों सेम है. देखिए एक्चुअली क्या
सर?
था. हाँ बोलो बोलो.
तो सर वही मैं पूछ रहा हूँ, क्या कैसे पता चलेगा?
हाँ सुनिए. देखिए एक्चुअली ये जो न्यूट्रल और आयनिक स्टेट का कॉन्सेप्ट है ना, दिस कम्स फ्रॉम द टू ग्रुप ऑफ साइंटिस्ट. One group of scientists studies that in case of organometallic compound, the bonding nature is predominantly covalent, right? When bonding is covalent, it means metal is neutral also and ligand is also neutral. So they calculate the electron donated by ligand to metal by considering that all the ligands are neutral. That's why we have we study neutral state donation of electron by any ligand. One group of scientists was that which studies those organometallic compounds in which bonding nature is predominantly ionic. That's why they consider that metal is present in a positive oxidation state and ligand present in negative oxidation state. That is, metal and ligand both are present in ionic state. That is why when we calculate electron in case of organometallic compound, either for calculation of metal-metal bond or either for explaining oxidative addition reaction, reactive elimination, in all these cases, we calculate electron by two method. एक neutral method and दूसरा oxidation state. Oxidation means ionic state, दूसरा neutral state. So हमको ये नहीं सोचना है कि कब न्यूट्रल होगा कब आयनिक होगा. आप
नो सर,
हाँ
मैं पूछा था लीनियर मोड और बेंट मोड कब होगा, ये कैसे पता चलेगा हमें?
okay. Listen, it depends upon the stability, right? Listen, consider one metal has Mxn, right, and No. If electron from this metal and electron from this ligand is equal to 15, right, then for this complex to have 18 electron, that is the stable configuration, it will have to be in linear mode. Why? Because when NO will be in linear mode, then it will donate how much electron? 3 and 15 plus 3 what? 18 electron. That means this complex will be stable, right?
Yes, sir.
If Mxn NO it has 17 electron, right? Then it will be this nitrosyl will be in bent mode, because in bent mode it will give 1 electron, then 17 plus what, 18, it will achieve stable configuration, right? This is valid for those complexes which obey 18 electron rule, right? That means major geometries of these complexes were octahedral and tetrahedral, right? There are many complexes which do not obey 18 electron rule, they obey 16 electron rule, right? Mainly 16 electron rule for what? Square planar geometry. The complexes which have square planar geometry, they do not obey 18 electron rule. Why? I will explain you later. Okay? It's easy.
Okay.
These things are very easy. 16
Okay,
electron. Then in this case, M, Xn, NO, right? Like then, if this has 15, then this will be what? Bent, because you have required, yeah, you required only one electron to complete, to achieve the configuration of electron clone, which provide stability. That means one electron. Then 15 plus 1, that is 16. So it depends upon geometry, right? Because on the basis of geometry, complexes obey 18 electron rule, 16 electron rule. If square planar geometry is there, then you have to think about 16 electron concept with NO, 3 electron, 1 electron, whatever the electron is required for system to complete 16 electron, then you have to think like that. If complex is octahedral and tetrahedral and it is going to 18 electron rule, then you have to think like this कि linear होगा कि bent होगा, right?
Okay, sir.
ठीक है, ठीक है बेटा. तो हम लोग अब नेक्स्ट क्लास में अब शुरू करेंगे कोई नया चैप्टर. ये तो दिस इज डेमो क्लास ओनली. तो नेक्स्ट क्लास I will start from chemical bonding, and I will request all of you to present in each class of chemical bonding so that you can have basic learning, so that you can easily understand coordination chemistry, you can easily understand organometallic, main group, block, all chemistry, because chemical bonding is the basis for inorganic chemistry, right? Right? तो वो समझ में आएगा तो आपको सब ये समझ में आएगा. ठीक है. अब इसमें एक दो चीजें होंगी जो आपको लगता होगा कैसे कैसे हो गया, वो मत कीजिए. वो हाँ जी बोलिए.
सर वो लीनियर में 3 इलेक्ट्रॉन शेयर हो रहा था ना एनओ की तरफ
हाँ
से.
हाँ, जब वो न्यूट्रल रहेगा तब.
ये सर एक बार वो फिर से बता सकते हैं क्या, आयनिक में
ओके ओके
मतलब जब वो लीनियर था.
ओके ओके. देखिए, 2 इलेक्ट्रॉन फ्रॉम एयर, 1 इलेक्ट्रॉन फ्रॉम एयर, 3 इलेक्ट्रॉन लाइक दिस.
मतलब एक पाई में जा रहा है और 2 सिग्मा में जा रहे हैं.
हाँ, 2 सिग्मा में जा रहा है.
ओके सर.
सर ये एन डबल बॉन्ड ओ के ऊपर ये डैश लाइन क्या है?
ये एक्चुअली बॉन्ड ऑर्डर इज 2.5, राइट?
ओके.
दैट मींस द 2 इज द कंप्लीट वन बॉन्ड ऑर्डर, 1 बॉन्ड ऑर्डर. ये 0.5 को रिप्रेजेंट करने के लिए है. जैसे देखिए,
अच्छा सर.
ये हो गया बॉन्ड ऑर्डर, कितना हो गया 2. अगर हम ऐसे लिखते हैं, इसका मतलब 2 है, बट ये कितना है 2.1, 2.3, 2.4 कुछ भी हो सकता है. मतलब पार्शियल बॉन्ड है, राइट? डॉटेड का
ओके
मतलब है
सर.
पार्शियल बॉन्ड, कंप्लीट बॉन्ड नहीं है. ठीक है.
सर ये
मतलब
ऐसे ही
बॉन्ड ऑर्डर इज
रिप्रेजेंट
लेस.
करते हैं.
हाँ, बॉन्ड ऑर्डर इज लेस देन 1. बॉन्ड इज लेस
ओके
देन 1, 0.9, 0.8, क्योंकि बॉन्ड ऑर्डर तो फ्रैक्शन हो सकता है ना. एमओटी में पढ़ा होगा आपने, बॉन्ड ऑर्डर कैन बी
यस सर.
फ्रैक्शनल. ठीक है.
यस सर.
ओके.
सर ये रिप्रेजेंटेशन बेंट मोड में नहीं होगा?
क्या?
बेंट मोड में जैसे आपने हाँ डैश लाइन लिखा है ना, जैसे लीनियर में आपने 2 डबल बॉन्ड के बाद एक डैश किया ओ में, ये बेंट में ऐसा नहीं होगा?
नो 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 नो, बेंट में ऐसे नहीं हो सकता, क्योंकि ऑर्बिटल का ओरिएंटेशन अलग है ना. देखिए, जब बेंट में आप करेंगे तो ये इधर आ गया ऑर्बिटल, अब मेटल इधर हो गया. अब मेटल की फॉर बॉन्डिंग ओरिएंटेशन ऑफ ऑर्बिटल मस्ट ना. अब ऐसे ओवरलैपिंग अगर करेगा भी तो ये एक ही लोग तो कर पाएगा, दूसरा लोग तो है ही नहीं ना इसका. तो इससे ओवरलैपिंग नहीं हो सकती है.
नहीं सर, ये जो स्टार्टिंग में जो हमने एनओ लिया ना, जिसमें मेटल
हम्म
बॉन्ड नहीं बनाया तब तक, मैं उसकी बात
हम्म
कर रहा था. जैसे आपने यहाँ पार्शियल मतलब वो डैश डैश लाइन लिखा है ना 2.5 बॉन्ड
हम्म
ऑर्डर का, इसमें
हम्म.
शायद बॉन्ड ऑर्डर 2 दिख रहा है, तो बेंट में
अच्छा,
2
एक
रहता
ओके
है.
ओके, रुको रुको रुको, ठीक है कर लेते हैं, वो ध्यान दीजिए तुम्हें. राइट,
यस.
कर सकते हैं सर. ठीक है.
यस सर.
ओके. बट यहाँ बॉन्डिंग नहीं कर सकते इस तरह से, क्योंकि एटलीस्ट सिग्मा बॉन्ड है ये. Next bond that is form that will form between metal and nitrogen, it is pi. For pi bonding, there should be side-wise overlap for both sides. So one side of overlapping is possible, other side there is no orbital, so there will be no interaction, right? That is why मैंने ऐसा दिखाया नहीं यहाँ पे, ऐसे सिंपली छोड़ दिया इसको. ठीक है, पॉसिबल नहीं है, राइट?
सर विपिन
हाँ
सर,
हाँ हाँ.
इसमें ना लास्ट वाले स्लाइड में बस इन लोगों को एक होमवर्क दे दीजिए, जिसमें नाइट्रोसिल के अलग अलग कॉम्प्लेक्सेस होते हैं ना, जैसे वो टर्नबुल्स ब्लू वाला है,
अच्छा.
ताकि ये लोग उसका ऑक्सीडेशन स्टेट निकालना सीख जाएं, क्योंकि वो कई बार नॉमेनक्लेचर में पूछ देगा या कोऑर्डिनेशन में पूछ देता है उसकी ज्योमेट्री मैग्नेटिक प्रॉपर्टी.
हम्म. तो अच्छा ठीक है.
वो इन लोग बस होमवर्क दे दीजिए, ये लोग अपना करके आएंगे, बाकी जब क्लास चलेगी तो ये लोग करेंगे. इंपॉर्टेंट एनो कॉम्प्लेक्स है, वो तुम लोग जो है एज ए होमवर्क कर लो, वो जेई लेवल पे तुम लोगों ने पढ़ा होगा. इंपॉर्टेंट NO कॉम्प्लेक्स जहाँ पे +1 वो शो करता है, कब वो न्यूट्रल रहता है, कैसे हम डिटरमाइन करते हैं, ये सारी चीजें।
तो अभी अभी पहले
हम्म
इनको हम वो बेसिक चीजें कुछ बताते हैं, ये सब चीजें, क्योंकि
हम्म
जब ये
हम्म।
पढ़ लेंगे ना तभी इनको समझ में आएगा कि कहाँ पे कैसे करें, नहीं से कर नहीं पाएंगे।
हाँ हाँ, नहीं मतलब बस